Last week I talked about the jet stream, a river of fast, high-altitude winds over the mid-latitudes. Having the jet stream overhead doesn't necessarily mean wet weather, so calling it a river of air isn't meant to imply stormy. But meteorologists do use the word river in a different context that is definitely intended to invoke visions of lots of precipitation. Here's what I mean. This satellite-derived animation shows what we call total precipitable water. Essentially, how much rain would fall if you could instantly condense all the water out of the air. Now here, maroon, orange, and yellow indicate higher values. No surprise, they're concentrated near the equator. But focus on the filaments of moisture that originate over tropical and subtropical oceans and extend into the mid-latitudes. These narrow plumes that look like taffy being pulled out of the tropics and subtropics are called atmospheric rivers. They account for about 90% of all the water vapor that flows out of the tropics into the mid-latitudes. Now, by the numbers, a typical atmospheric river might be 1,000 miles long, 250 miles wide, and focused in the lowest mile or so of the atmosphere because that's where most of the moisture is. Atmospheric rivers that affect the U.S. West Coast get the most attention. The most famous is probably the so-called Pineapple Express that originates near Hawaii. Typically, just a few atmospheric rivers account for as much as half of the precipitation that falls during the rainy season, so they are vital to the western water supply. Now, in particular, California has huge year-to-year precipitation variability. Check out the ups and downs on this graph of annual precipitation. The average is about 22 inches a year, and the changes from year to year average about half that. This large year-to-year variability is mainly the result of the wettest days, which are typically related to atmospheric rivers. A dramatic example of the impact of atmospheric rivers in California comes from the winter of 2016-17. In late December 2016, more than 40% of the state was in a prolonged extreme drought, the red and maroon here. January and February 2017 brought a series of atmospheric rivers, fire hoses of low-latitude moisture transported northward into the Golden State from the subtropical Pacific, ahead of strong low-pressure systems. Each atmospheric river bringing substantial rain in the lower elevations and snow in the mountains. By the end of February 2017, extreme drought was erased from California for the first time in 3 years. More recently, just last month, here's how a succession of atmospheric rivers piled up the precipitation in California. The purples you see along the coast and in the Sierra Nevada, where the snowpack is doing very well, indicate more than 20 inches of liquid equivalent. Here's a before winter versus late February comparison at Donner Pass in the central Sierra just northwest of Lake Tahoe. More than 20 feet of snow reported at some ski resorts just in February. Now, here in the eastern U.S., we typically don't use the atmospheric river terminology, even though nearly all big East Coast storms tap into at least some subtropical moisture. Are any juicy storms in our future? Stay tuned. The extended forecast is next.